Good afternoon, everyone, and welcome to the Make It Smart Hub Design-Led Retrofit webinar, delivered by the Construction Scotland Innovation Centre. Hello, my name is John McLennan, and I'm an Innovation Centre Manager with the Construction Scotland Innovation Centre, based in Inverness, covering the Highlands and Islands and the North East of Scotland. Just before we get underway, I'd like to highlight some housekeeping points to help the webinar run as smoothly as possible. Firstly, the session is being recorded today, and the presentations will be available following this webinar or on YouTube. All applicants will be on mute for the duration of the webinar, but I do ask you and encourage you to ask questions throughout. To do so, click on questions in the control panel, type in your question and press send, and we'll try to answer as many as we can during the Q&A session at the end. Your feedback and opinions are extremely important to us, and we will note each and every question, and if we don't have time to answer them all today, we will endeavour to incorporate them in future presentations in the series going forward. There will be interactive polls displayed on your screen in between each of the segments today. Please answer them and we can display the results for everyone to see during the webinar. This will also help inform the direction of future webinars in the programme. In the background we have Danielle, who will make sure everything runs smoothly. And finally, in the spirit of all good event management, no fire alarms are planned for today, but if you should hear one, please make sure it is your own before you vacate the building using the nearest available exit. I want to briefly introduce you today to CSIC and what it does to drive forward construction in the Innovation Centre. I'm just waiting for my presentation to come up.
Hi John, it's up on our screen. Might be behind one of your apps.
I've got a funny feeling I called that down. Just bear with me.
Yep, we can see it again now. You can.
You can see it now.
Yep.
Okay. Sorry about that, folks. So welcome to the webinar with myself, Bill Butcher, and Angel Morales Aguilar. Just want to briefly talk you through sorry, Danielle, I can't move the slides forward.
It's okay, let's just take it back and try again. So it'll come to you again, John.
I can't see my presentation on my laptop screen. That's the problem. I've no way of minimizing what my webcam to show what's in behind.
You want to turn off your webcam? That might help.
There we go. Okay, I think we're getting there. Sorry, folks. First time that's happened in 7 webinars. Innovation in the built environment, the Construction Scotland Innovation Centre. We are a beacon of innovation for the built environment. We are responsible for ensuring the sector changes to be more sustainable, relevant to society's changing needs, and has the best economic outlook. We are one of 7 innovation centres in Scotland, funded by the Scottish Funding Council and the Scottish Government. Each centre has its own theme. One of our most valuable assets is our connected ecosystem. We link together industry, academia and the public sector to drive forward innovation, supporting the built environment to achieve net zero carbon through innovation. Our work revolves around 4 key themes that we see as being the key to delivering net zero carbon in the built environment. These are digital transformation, advanced manufacturing, building sustainably and culture change. Our work is delivered through our connected ecosystem, using our connected ecosystem to engage industry and innovation, collaborative projects, working on collaborative innovation projects with industry and academia and the public sector, our innovation factory, giving industry access to a range of advanced equipment in our factory in Hamilton, and future skills programs, supporting the industry culture change through future skills programs. Quickly, some examples of our work. The K-Brick, recently successful in securing a significant £1 million of investment, the world's first recycled brick. Glulam Solutions robotic cross-laminated timber joists. Our work supplying an online immersive learning tool during COVID. And Offsite Solutions Scotland, a formal collaboration partnership between 10 leading offsite manufacturers sharing R&D and training needs and best practice. We also have the Make It Smart Hub, particularly for the Highlands and Islands. This is the platform that it's delivered via today. I'd encourage you all to visit the Make It Smart Hub, register there and gain access to the valuable insight and expertise that's on the platform at mis-hub.com. So far, we launched in November 2020. Website with the matchmaking platform has been established. We've delivered 6, this is the 7th, and we've got over 300 company engagements so far. We're in the process of buying new equipment, and we have 4 key themes of explore, connect, learn, and do. In terms of connect, we've got, as I said, we've got our matchmaking platform. On there, you can share challenges and solutions. And just to give you one example, someone posted a challenge from a company in Orkney. My challenge is to find an innovative way to create these architect-designed beehive structures, possibly using 3D printing and cutting-edge materials suitable for extreme weather environments such as Orkney. And Norse Program have posted that challenge on the website, and Construction Scotland Innovation Centre will be working with them, drawing up a project scope to see if we can solve that challenge. So just finally, come on your innovation journey with us. And I'd just like now to hand over to Bill. Thank you.
Hang on. Can everybody see that screen, Danielle?
Yep, that's great, Bill. Thank you.
That's great. Thank you. Hello, everybody. I've only got 10 minutes and I could be talking all week. So this is just a very quick synopsis of what we do here at Green Building Store. We're design and build and components suppliers and designers. So we come at these projects from project management side of things. We work with architects in a partnership type way. So partnership is a big part of our work. We don't actually do competitive tendering because basically what we're doing is beyond what the industry is used to doing. Hopefully it won't be. So I'll just run through quickly. So we basically work from the passive house methodology, fabric first. So insulation, continuity of insulation, forgive me if you know all this already. Minimizing thermal bridging, which is easier said than done with retrofit. Minimal and continuous air tightness barrier, if possible, for lots of reasons. Air tightness, it's for comfort, for sustainability of the structure of the building itself, and for energy, lowering energy consumption. And part of this is having an MVHR system, which is mechanical vent heat recovery systems. We think that they work efficiently when we get an air tightness of below 3 air changes per hour. So that's what we'd be aiming for in these retrofits, hopefully lower. In retrofit, one cannot optimize solar gain for obvious reasons, or the form factor, which is surface against volume ratio. So far harder than new build. This is the PHPP that we use for value engineering. So even if we're not going to go down to the passive house retrofit standard of Enefit, we still use this to value engineer, as I said before. So it's a 38-layer spreadsheet, which comes right through to the end, this verification sheet. For certification, which is rare, to be quite honest, in the UK, we would be aiming for 25 kilowatt hours per meter squared energy demand. which is about 1/10 of the most of our older buildings, I would suggest, and a heating load of maybe around 14 watts per meter squared. So on a 100-meter house, that would be 1.4 kilowatts when it's -10 outside. I mean, that is the optimum. We don't expect to get there on most of our retrofits, but we will taking that methodology and having a whole house plan fabric first. We also have high risk with, particularly where we are on top of the Pennines here. Maybe it's like similar to you in the Highlands and Islands, in that we've got high rainfall. So particularly with solid walls, we are very we've got to measure and work out what is the best measure for insulating walls. Particularly external wall insulation is in some ways the easiest way of retrofitting, because you keep the walls warm and so forth. Otherwise, we've got rain-driven damp if we're doing it going internally, which all of these projects are, rising damp and interstitial condensation from relative humidity inside. This is an example at Cumberworth, I think back in 2014. This bit here of the building, so this is our house. This is a rubble-filled stone and stone wall of an old barn conversion. This is a modern 1992 extension. We have to treat the walls, we treat the walls differently using that software program called Roofie I mentioned earlier. So on the cavity wall side, where we've got a cavity and DPCs and cavity trays and so forth, we find that we can get away with a man-made material. In this case, it's fiberglass, but we use an intelligent membrane. We model this build-up here. The timber actually is a service void, but look at the air tightness measures with this intelligent membrane, taping and so forth. On the barn side, the ex-barn, we have to use more specialist materials. Wood fiber wasn't going to be good enough where we are exposed up here. So we tried this material. It's called Tectem. It's perlite from Germany. We have moisture meters in most of these projects that you can see, help of Leeds Beckett University, the AECB, and in this case, Knauf, and we measure their performance over time. It is expensive, but we found that it works excellently. We're looking for a WME, wood moisture equivalent, of around 20 to 25%. And this material has sorted it out on this barn where they had a lot of problems beforehand. Thermal bridging. Look, we take the insulation through intermediate floors, so we'll move floor joists, for example, to continue the air tightness strategy and insulation strategy. In this case, we didn't want to interfere with the size of windows. We'd replaced these 5 years previously with triple glazed windows. They weren't going to pay for more. So look, we've used VIPs, vacuum insulated panels, with a far better lambda value for the reveals. Here you have to deal with the intersecting partition walls, particularly the masonry ones. Look, they're a big thermal bridge, so we're trying to warm them up to alleviate moisture and mold growth. And also thresholds. Here we've used foam glass around steel joists into walls because we want to keep the steel warm. This is a this is a barn and farm house renovation in Meltham, another village, in fact the village I live in. So this is what we go through. Yeah, so we've identified the wall, we've identified the risks, we come up with a potential solution, and in this case we're using something called diathanite, which is from Italy. It's basically lime, cork and diatomaceous earth, and then we check it with Roofie as an analysis. Do we need brick cream, for example, on the outside for it to maintain that level of 20 degrees, just going back. Oh, how do I go backwards, Danielle?
It should be at the bottom of your screen on the left, if it'll allow you to.
Oh yeah, sorry. Yeah, I apologise. So here we are. This system sprays on and has got a lot of advantages, but again is, to be quite honest, expensive. But actually, it does everything in one. So it's airtight, it's capillary and vapor open. It's hard, so you can hang cupboards off it and things like that. And it looks like Santa's grotto, doesn't it, actually? But then you've got a lime finish on the outside. This, I feel, is the best way of dealing with high exposure masonry buildings. But again, it costs, but there again, there are no risks, well, very low risks with it. This is another methodology we've used. This is for the Yorkshire Wildlife Trust, an education centre for the kids. This is the building I really love, actually. We had to, in fact, we built a box within a box, timber frame to hold the masonry up. All these portholes are actually concrete with stainless steel bars set into the masonry, and we anchor it into the timber frame. This is an example. Look, we've got all those things. We could go back to those pillars of wisdom earlier if you like. So continuity of insulation, air tightness, concrete, and chipboard here as what's it called? Pro Plus, I think, this board here. But we had to ventilate the cavity, and we lose a lot of floor space with it. But we're able with this to get down to a U value of 0.15. When we put internal wall insulation against the masonry wall, we don't go below 0.35 U value. It's deemed as dangerous otherwise towards moisture buildup, particularly around intermediate floor joists. But we aren't purists, and Ahul, who will come after me, will disapprove of this, but we will use Kingspan. We will use polyurethane. We're pragmatic. We've got climate change now. People do not want to lose floor space, and this is really quite the cheapest way of doing it. And if it goes through Roofie and it's showing that there is minimal danger to timber within the walls and to stop any mold growth, we'll use polyurethane. A lot of companies that we work with would use wood fibre here, but of course the lambda value for wood fibre is half as good as polyurethane. This is maybe a moral argument. I'd be interested to see what people think later. This is the last project we've done. This is at Holmfirth. Here we are again spraying with a new version of the diathanite. It's called Thermoactive, and we're down to a 0.37 lambda value. So to get to that 0.35 U value, we're spraying at 85 mil of thickness. Windows are really important at all of these jobs, where we're sorting out thermal bridging around windows here. Look, air tightness taping and wind tightness outside. We're particularly happy with this job actually in this way. So hopefully I've done that within the 10 minutes. We've got all of these projects on our website as free resources. We're open source, and we also talk about our failures. And thank you very much.
Thank you, Bill. That was a great insight. And what it does demonstrate is that it's not a one-size-fits-all solution. And particularly just now, until those innovative solutions become more mainstream and commercial, using pragmatic and practical solutions in the short term, whilst also taking account of occupancy and owners' desire for the building as well. And just before I hand over to our next speaker, it was slightly remiss of me in my introduction. I should have introduced Bill a bit more formally, should I say. And Bill has been a project leader on a range of passive house and radical, as I'm sure you would agree, retrofit projects in the Huddersfield area, including the Denby Dale passive house. Bill is a certified passive house consultant and certified passive house tradesperson. He also serves on the technical panel of the Passive House Trust and teaches on the construction module of the Carbon Light CEPH designer course. So it's great to have Bill on today, and we'll hear more from Bill in the Q&A at the end of the session. And so secondly, I'd just like to welcome Angel Morales Aguilar of LDN Architects. Angel is a partner in LDN Architects, a Passive House certified designer and an advocate for conservation architecture, and is currently involved in a range of retrofit projects. Angel, over to you.
Thank you, John. Hope you can all see that all right.
Yep, perfect, thank you.
Well, it's, as I mentioned to Bill before, it's a bit of an honor to come up to him, but also a bit of a responsibility because Bill is quite well known in the retrofit and the passive house ecosystem as somebody who knows a lot. So while Bill has been focusing on all different options and solutions and details, my presentation is going to be more about process from an architectural point of view. And I'd like to, and just before starting, just to kind of highlight that this project we're talking about, we are still in this journey. This journey is still kind of halfway through it. So we're now engaging with the contractor, but I'm not going to be able to show finished images or different details being applied. But this is what I hope to share today is how we have approached the design stage of the retrofit. So first few words who we are. We're LDN Architects. That's us. A few people are no longer there. Some people are new, but by and large, it's just us. It was founded in 1957 by Graham Lowe and James Dunbar Naismith. There's about 40 people, including 7 partners. We have offices in Forest and Edinburgh. And we do conservation, public buildings, commercial, residential, and pretty much everything in between. And that's me with my kids and my wife. And I studied in Spain, Germany, and Poland. I'm a partner at LDN Architects since 2020. A great year to start. I've been a certified passive house designer since 2019, although I have known about passive house since the early 2000s. I also deal with carbon footprint calculations using one click. Currently working on a retrofit. And as the rest of my office, I just work on pretty much everything with a very strong sustainability background. Now, I just want to go run through quickly some jobs I've done because the project I'm presenting today, the house on the slope, is quite relatively small compared to what we've done in the past. I've done retrofit and refurbishment projects in public buildings of a certain size, like this one in Aula, where we did a lot of retrofit using the retrofit principle, which we have now used in other projects, also been applied into larger community projects. This one in Dumfries, the same thing, where we also have sort of this idea of the new and the old and how we manage to improve and try to make new buildings and historic buildings work together, but at the same time for them to survive for a bit longer, introducing new elements. And I'm a big advocate of the use of natural materials like timber. Also working in quite enclosed sites in central Edinburgh, like this one, Royal College of Physicians of Edinburgh. Again, is about inclusivity, sustainability, and ensuring that historic buildings remain relevant. So, onto the actual house I'd like to talk about today. The house on the slope, it's on the west coast of Scotland, stunning location, absolutely beautiful place. The history of the building is very interesting. It was LDN's project number 3. It was designed by Graham Lowe when he was in his early 30s, and is a house of its time. Beautiful, modernist, simple construction, but they still use some traditional materials like timber, stone, and in a somehow audacious way, because some of the detailing that they used was quite yeah, they didn't really try to be innovative there. Not everything works, but definitely is a beautiful building. Obviously, the system relied on cheap fuel because the building was not insulated at all. It's just a timber kit. The space heating is done via a warm air system fed over a boiler, a gas-fired boiler, which obviously a house which is not insulated and not very airtight means that it just needs to be constantly be heated just to retain a little bit of warmth. As you can see here, the 25th of October 1957 is the date on this drawing, which we found. We found the original drawings that had been kept by the client. And yeah, well, my dad was 8 years old when this house was built. So for us, this is part of a heritage that I think is worth maintaining. When the client came back to us, they basically were concerned about the failing cladding they had, but they themselves suggested that maybe we could just knock the house down and start over again. And we said, no way, the house is worth keeping, and we should just refurbish it. As I said, we unearthed some drawings that helped us understand how the house had been built, because obviously the house, which had an extension built in the 1980s, there were no drawings available that we could use. So that's the first part on a retrofit project like this, is creating a knowledge base where you can basically start working off your own drawings. But before that, that's the house as we found it. As I said, beautiful site, really nice house for our client and his daughter. Our client is in his early 80s, so comfort, issues of comfort, accessibility are quite important, but also the running cost, which I will touch on in a minute. Obviously, over the years, the house had been changed, altered, but the beauty of the spaces and the original detailing still shows through. But unfortunately, a lot of the, as you can see here, up on top of the roof, probably not being particularly conscious, health and safety conscious, as architects very often are, but you can see the views and the absolutely stunning site where the house sits. Obviously, the house is quite tired, roof membrane was failing, not a very sympathetic detailing all throughout. So in a way, it was a house that actually needed some TLC, really. The timber cladding was failing, with a lot of felt just had been just wrapped, just not letting the timber breathe. Then the build just showed that the ground floor, the solum was actually quite dry, which means that it has worked quite well in terms of as a strategy for keeping water out. But it's completely uninsulated, which means the main part of the house is just, yeah, it's absolutely freezing in winter and most of the year, really. The services are very dated, and here is an interesting thing. The different clients, owners of the house, our client is the third owner. They had basically approached different tradesmen just to help them resolving some of the problems they had. And here I have to say that nothing wrong with tradesmen, but very often there is a lack of understanding that you need to take a holistic approach when you really want to resolve these problems. So if you go to a heating specialist, he'll just change the boiler, not even thinking that the ductwork is uninsulated, like in this case, or poorly insulated. This is the extension where some insulation was put in, but it wasn't kept in position, so it's not airtight, so its performance is diminished greatly. So that's why I think it's important for people who want to do a retrofit of their houses to contact an architect that can give them a wider, a more holistic idea of how the problems can be resolved. Some pretty sympathetic services, interventions like this, flues come out of the plant room, which is here. There was a number of problems with the heating system. Some of the plenum connecting the gas boiler with the main ductwork was flooding regularly, so what the client was getting is warm but humid air, which obviously created a lot of issues of internal air quality, particularly because his daughter is asthmatic. So in a way, what we had to do, as I said before, is we started by creating our own knowledge base. We created 2D drawings, and from those 2D drawings, we started to analyze what the problems were. All these coloring lines basically describe the different things that had to be done in order to achieve what, which is a very interesting point. So at this point, we introduced to the client the concept of passive house. They had heard of it. They didn't know much about it. So I gave them a chat about it, which I've done a few times, where just basically explain pretty much what Bill just did, explaining what the principles of passive house are, but trying to keep them quite, not patronizing, but so people understand the principles. Sometimes we get a bit too techy. And that means that when we actually decided to start working on the project, or actually stating the scope of it, we realized that the client didn't really know how much it was needed, which meant as well that when we prepared these drawings, we thought about, okay, creating 3D visuals that help them understand which parts of the house we were thinking about touching, which ones maybe could be left out. We did this always do this as a matter of fact, But in this project, really helped the client understand in which areas we're planning to work the most. We even created a 3D of the structure so they could understand if we had to go back to sticks, what that actually would mean. But then I've just described sort of what a house is. So the rest of my presentation is going to be, you're not going to see any more photos or technical details. It's more about a mental diagram of how I see, after my experience in this project, but also in other projects, the three elements that are, in my view, to be considered mostly when you talk about a retrofit project. And they are all evolved around cost, performance, and disruption. In the case of the house on the slope, performance was the first thing we thought about. Obviously, the house is failing in many ways. So how can we tackle that? What is the actual performance baseline we're going to create? And for us, that was passive house. We talk about a thermal envelope, air infiltration, moisture management, sound comfort, durability. But that led us to something that Bill mentioned as well before, and is the NFIT paradox. That is the fact that to achieve NFIT, the level of performance you need to do makes very often the project completely uneconomical. Even if the client wanted to get to the best performance they could, NFIT is a good gold standard to aspire to, but very rarely is something you can really obtain because the costs are just too high. We basically used PHPP not just as it can be used not just as a certification tool, but also as a design tool. It helped us sort of set the baselines of levels of insulation, infiltration, and things like that, only to discover that most of them were actually maybe too expensive, but I get that in a minute. So the details we prepared at this stage were basically scoping the project were all supposed to be for passive house standards. Huge levels of insulation, air tightness, and basically recladding pretty much, basically going back to the sticks and building the house over again. The same on the ground, trying to break all this passage of air. I mean, you can see on the top here that the absolutely tiny amount of insulation of anything that was inside. It's actually quite interesting because the client installed PVC windows about 10 years ago, and the windows were so thick that they had to create like an apron inside the house because the walls were too thin. The next item to consider is cost. And obviously this is very often the king. King is always, I mean, the cost is always the driving factor, but not always. And I mentioned that in a minute later. Cost actually has a huge impact because it limits how much you can do. Because also cost also has a lot of different, there are different ways you can look at costs. From capital costs, upfront investment, obviously, running cost, which is also a form of deferred investment or bills. And that's something that's going to be more and more, it's more and more important because of the higher cost of energy going up. But also environmental costs, which we do find some clients are quite interested on, both from an operational carbon point of view, that means the carbon you produce to keep your house warm, also the embedded carbon, the energy of the energy used to produce the materials you use. And this is going back to what Bill mentioned before. I do advocate for natural materials, but I understand as well that sometimes we need to use petrochemical, the evil and everything. But in my case, I always try not to use them. And in the case of this, the house on the slope, we've gone for carbon fiber throughout. Sorry, wood fiber throughout. Also, yeah. So what that meant is that we end up with 5 different options. 5 different schemes, which we had to go through to style what the client actually wanted. And that's a process that I think is necessary, and we need to do it. And we need to hone our tools to make sure that we can go through all these stages without upsetting our client, but also without upsetting ourselves, because this is a process where the client is getting to understand how much you actually need to spend on this project. And the last one, which is quite important, is disruption. And disruption is key because it has loads of different dimensions: physical, operational, emotional. In the case of the house on the slope, we talk about a man in his 80s who really can't face the fact of leaving his house, so or even moving storage, let alone the dust and noise. So all the design we did, all the discussions we took, had to take that into consideration. So, for instance, we show them the different bathrooms they could have. So in a way, we brought them along with us to say that the disruption they're going to have to suffer, which is unavoidable, will make sense by showing them different options and something that was important for them. When you put the two together, you get to different kinds of projects. When performance and cost are the main drivers, disruption is not an issue, it means you're probably in an empty property, which means that you have a limited budget and you will obtain a suboptimal performance, but by using the right detailing, because you're not disturbing anyone, you can actually optimize the performance. When cost and disruption are the main drivers, which is the main, what I would say 80% of the case in most projects, then the performance has to be careful with the specification, because you only have very little money you can spend. So the cost is limited, but disruption, because it's an occupier, you need to take that into consideration as well. And the last one, which is the case of the house on the slope. I don't mean that the cost is not an issue, but it's not as much as an issue as the fact that the client wants their house to be warm and they want to stay in the house, which means the disruption has to be completely considered. And in this kind of cases, yeah, specification very carefully selected can help you achieve the performance you want, because the cost in this particular case is not a huge issue. It means if you play and you know and you choose the right things, you can get an optimal design. It might not be Retrofit, and in this case it will not be, but it will still improve hugely the comfort of the occupants, which is what you should focus on in a job like this. Is basically the occupants and their comfort is always a driving factor, but in jobs like this it is even more so, because they're going to remain in the house, and staying in the house means that they will suffer what we would normally do. Imagine when you do up your house, but it's you doing it. Imagine when it's somebody else just walking through your living room in a way. So that's why for us in the house on the slope is the occupants that plays the main driver when it comes to making this sort of decisions. That's something you need to make. All in all, in reality, all these three things are always to be considered together. We are in a point where we've finalized pretty much the design stage, and we've now got into a negotiation with a contractor. So watch his space, as I say, and hopefully I can present to you next year how all of this actually turn out to be. So thank you very much.
Thank you, Anna. That was a fascinating run through, and in a very complicated project, and advocating, the design-led aspects, and the desirable to have architect-led approach as well, and also linking together performance, cost, and disruption, and taking all of those factors into consideration. And I think you're right. We'd be delighted to have you back next year and let us know how it's going. So before we come to the two spotlight sessions, I just want to have our first poll. So how do we avoid atrocious retrofitting of homes? Please select one. Just another few seconds. Okay, and the results there. So, how do I avoid atrocious retrofitting? And there's a clear leader there with a holistic process approach with an end goal. So that kind of fail to plan, plan to fail. So absolutely, have an end goal and make sure it's all planned out. So we're now going to have two spotlight sessions. These spotlight sessions are available to early stage and startup businesses. So I am delighted to invite Ernie Lamza of Hyperduct to have his 2 minutes, and it is timed, Ernie. So 2 minute spotlight session. Over to you, Ernie.
Thanks very much, John. And in the spirit of Monty Python, now for something completely different. Can everybody hear me okay?
Yep, loud and clear.
Very good. As John said, my name is Ernie Lamza, and I want to talk to you today about Hyperduct, a dynamic young team of artificial intelligence specialists from Aberdeen who produce software products based on big data analytics, machine learning, and other innovative digital technologies. Hyperduct specialists also help companies to identify what digitalization could do for their businesses. We call this digitalization assessment, and how it can identify key areas where digitalization could benefit your business is the subject of this spotlight session this afternoon. So how does it work? It starts with input from you regarding your data. How much is there? Its quality? What you currently do with it? We then hold a 3 to 4 hour online session with you, bringing together your knowledge of your business with our expertise in AI-based solutions. This involves open discussion and exploration of what could be achieved through digitalization, how it might work, and what difference it could make for your business. Working collaboratively, We follow our structured assessment process to generate a list of potential digitalisation activities that would benefit your business. We then rank them, prioritising on cost, benefit, and ease of implementation, not forgetting QHSE or net zero issues, to produce a prioritised list for your business to consider. Next slide, please, Danielle. So why do a digital assessment? It combines your knowledge of your own business with our expertise in AI to reveal important insights. Together, we identify digitalisation routes to value and improve competitiveness. It provides you with access to specialist artificial intelligence know-how that you typically don't have in-house. And it's quick, easy, and affordable, leading to actionable activities to benefit your business. So digital assessments are applicable to all companies, large or small, and in almost any sector or industry, including construction, of course. So if you're interested, please get in touch today. Our email address is on the page, info@hyperdapt.com. Thanks very much.
Thank you very much, Ernie, and time to perfection. And I do see a real market opportunity for data going forward, including retrofit, in terms of monitoring, smart monitoring, measuring thermal conductivity, etc., and interpreting all that data. So thanks very much, Ernie. We'll now go to our next spotlight session, which is Gary Smith of DCarbon.
Good afternoon, folks. Are we ready, Daniel?
We're ready. Yep, ready when you are. Thanks.
Okay, so it's a pleasure to introduce you to DCarbon this afternoon. We're a new startup business in Aberdeenshire, and our mission is to turn the toxic fumes from fossil fuel home heating systems into clean air. Next slide, Danielle. So in the UK, we've got 29 million homes that use fossil fuels to heat, and that equates to 73 million tonnes of CO2 per year, and it equates to 11% of all UK greenhouse gases emissions. Next slide, please, Danielle. So if we look at that global greenhouse gas emissions by sector, if you give it a click, Danielle, you'll see the triangle there outlines what the home heating basically emissions are in comparison to the rest of the emissions. Next slide, please. So if we look at that on a household basis, where approximately 9 tonnes of CO2 is being produced per year on average for an average UK home. Next slide. And if you look at that and break it down, that equates to almost 30% is due to heating alone. And then the final click, and to meet our UK targets, 2050 net zero targets, we've got to reduce that footprint by a massive 95%. So you can see all that's going to have to be reduced down to 5% what it currently is. So next slide, please. So if you look at our competitors and where we fit in the market, down the left-hand side, you'll see the renewable heating sources, ground source, air source heating, electric storage, hydrogen's coming online. But you can see there's quite a lot of expense occurred with them and a huge disruption. You might be lifting floorboards to install underfloor heating, etc., to accommodate these technologies. We want to be in the opposite direction. We want to be up in the game-changing right-hand top corner where we're affordable and the convenience to change is minimal. Next slide, please, Danielle. So how are we going to do that? So we're going to basically take the harmful emissions from your fossil fuel system, and we're going to basically filter it and produce clean air at the other end. And by filtering it, we're going to take out particulate matter. We're going to take out the toxic gases via a CAT system. We're going to take out the CO2 by sequestration, and then we're going to have a monitoring system as well built into the system that can effectively give you information on an app or be transferred to your local or national authorities. Next slide, please. There we've got a conventional system, and it just basically gives you an overview of the gases coming out. And basically what we want to end up with is producing only H2O, water vapor, nitrogen, and oxygen at the tail end. Next slide. If you just click through it, Danielle, to the end, you will see we've got gas is probably the predominant one in the UK, which we'll target first, but there's also oil, wood, and coal fossil fuel systems, which we will address later on in the life of the organisation. Last slide. So DCarbon. So what we're trying to do is heat without pollution. Thank you very much.
Thank you, Gary. Thank you very much for that and that quick run through of DCarbon. So we're just going to now proceed to the next poll. Danielle, please. And while we're just waiting for that poll to come up, if you've got any questions for our panelists today, please put them in the chat and we'll catch them at the end. So our second poll today is, what do you believe is the main barrier to retrofitting homes? No one size fits all. I'll let you read them. So interestingly there, the cost is clearly the leader in terms of the main barrier. I think we would all agree that they're all barriers to retrofitting our homes and on all key challenges going forward, but certainly cost is one of them. Interestingly, I heard last week that if we were to replace all our gas boilers or our fossil fuel boilers and heating systems in homes in the UK and Scotland, it would cost about £250 billion to replace all the boilers, and roughly about £10,000 per household. And the challenge was, well, who pays for that and how is it paid for? So that concludes the panel session and our spotlight session. So we're going to move on to Q&A. Let's address a quick technical question and acronyms question, and I think we can put this one to Bill. A quick question from Emil in the audience. What is Roofie analysis? Bill, please.
What is Roofie? Can you hear me, John?
Yes.
Hang on. It is a software program from Central Europe, of course, and I don't know what the capital WUFI stands for. Angel might be able to tell us, but it models an element, usually walls, which takes into account where you are in the world, orientation, and particularly the material build-up through it. And it predicts the performance over several years. And what you're looking for is a drying out of a wall, or at least it's stabilizing at around that 20-25% WME. 20% WME is when timber can start to rot. So that is what's going on. And of course, if we put in, as we know, vapor blocked internal wall systems, where we've got moisture buildup through either, through rising damp, rain-driven damp, and interstitial condensation because of badly installed internal wall insulation, we'll basically get rotting floors, joists in the walls, and mold growth and health problems going forward. And in fact, a lot of the suppliers who went into systems that do not take this into account well enough have withdrawn from it because they were in litigation problems. So that's just a warning, actually. IWI is a complicated business, internal wall insulation.
Okay, thanks, Bill. We know there are environmental benefits, social returns, and it's sometimes more cost effective to retrofit rather than demolish or reconstruct. So a question from Jennifer, Angel, did you consider a demolish new build option for House on the Slope?
Yeah, if I may just say just before Bill, as I mentioned in my bio, I studied in Germany. Basically, Rufus stands for Institution, Warm and Moisture. Basically what it does is, as Bill said, the problem we have these days is that we calculate at one point in time, and that's all we do. We don't consider that actually moisture builds up in the built fabric over time. And that's what the Roofie software does very well, because it doesn't consider just now and this condition, it just thinks about the next 30 years. Yes, no, the answer is no. We didn't even think about that for a number of reasons. When the project landed on us, on our lap, the first thing I did was I spoke to Sir James Dunbar Naismith, who is in his early 90s and whom I really wish, I mean, actually hopefully see him in November. We have an event in Edinburgh. He was pivotal for the creation of the World Heritage Site in Edinburgh. So it was fascinating to hear the story of how the project came about. And for us, the demolition of such a fine piece of architecture would be a problem. And I think not only because of some sort of hubris or pride, which there is some of in the case of it was our office which designed this building, it's also because it's a wider issue about what do we do with modern heritage. There's too often a very quick decision to demolish things, to knock things down because they're old, because they're made of concrete and we just don't like them. And we don't appreciate that by doing so, we are basically demolishing our own heritage. There's going to be like a huge gap. So in 100 years' time, people are going to say, so what happened between the 1930s and the 1980s? Nothing was built because there's nothing left. And that is a complete nonsense, particularly because in the 20th century, there's a data many people don't know. The humanity we have built as humanity more over the course of the 20th century and before the entire history of the humanity before that. So the amount of stock we have, it's huge. And the response cannot always be knock it down, build something new. Particularly when what you built new is crap, excuse my French. So I think that retrofit is a moral obligation, but also in terms of achieving our target of CO2 emissions, demolition is just not a way forward.
Okay, thank you. A quick question from Stephen. Do the panel have a comment on PAS 2035?
PAS 2035. Yes, my colleague here, Sarah Price, actually helped construct this, the PAS 2035. I don't have great knowledge of it. It is what we do already, I'm led to believe, in that whole house strategy. But it's actually trying to roll it out as a whole. And I think it's very laudable what it's trying to do. But it does rely on retrofit coordinators, as they're called. And this relies on individual people or organizations actually coming up with these whole house plans and actually helping organize well, what we're showing you today actually is less risky retrofit at reasonable costs. And giving choices. But of course, all of this is really, it only comes down to how educated and wise, should I say, these retrofit coordinators are going to be going forward. We can't just have a tick box session from people that don't understand buildings. So it's, it's a long road to go up to get this moving in a reasonable way where they don't fail and potentially we all get a bad name from it.
I think that if I may say something, I think the good thing about the retrofit coordinator is that we cannot all expect to be like Bill. You cannot expect every builder to be like Bill, because in fact, no, Bill is pretty unique for two reasons. Because he cares, that's quite unique among contractors, and B, because he knows. And it's very common that you find contractors who don't understand building physics. They just, although they work with buildings, they don't understand how they work. We're talking about science here. There's no opinions about how water moves through a wall. That's basically based on a formula. So what the PAS 2035 is trying to do is that we create this body of professionals who, although they're not as knowledgeable as the likes of Bill or others, at least understand the basics of what you need to look at when think about retrofit. You may not understand absolutely everything, but you know that you need to consider moisture management, you need to consider thermal bridging, you need to consider air tightness, and then you're able to look for help. Okay, I don't know how to do this. So I go to an architect, I go to a passive house consultant, whatever. And I think that's why I think is a step in the right direction. But however, as Bill said, it's not going to solve everything. It does need to be supported by an environment, an ecosystem of consultants who support these professionals to deliver these jobs. And I think that, and I always say this, is that unfortunately, contractors are the weak link, because anyone can be a contractor. Nobody really asks you to prove that you can do what you can do. And a lot of the mistakes that we do in retrofit will show up in 10 years time, by which point your company might be under, and so I think it's a step in the right direction, but definitely is not a silver bullet. It's not going to resolve everything.
Yeah.
Okay, thank you. So we're coming down to the last 5 minutes. A couple of other questions. So one for Ernie. We know that the construction sector lags behind other sectors in terms of digital adoption. What do you think the construction sector can do, Ernie, to accelerate that adoption of digital?
Well, it's not obvious why. I guess to ask the question, why does it lag behind is the first part, and it's not entirely obvious, but I think it may be something to do with the jargon that is used behind digitalization. There's lots of buzzwords, machine learning, the big data, and what all these things mean, and what could mean in a practical sense for the companies. But I think the offering I was talking about today in my spotlight talk is something that any company can do, a large or small, to try and work out what's right for them, for their business, and how can they apply the really powerful techniques that lie behind artificial intelligence and digitalization to help them make more money, to help them be more competitive, to help them get ahead and stay in business. So I would encourage everybody to give me a call, get in touch with me. Can't give me a call, he didn't give me a phone number, but I've got an email address there. But it's there's a huge amount of money spent in construction every year, so there is a tremendous potential to spend more wisely, and digitalization can help with that.
Thank you, Ernie. So a question for Gary, and I appreciate a succinct answer, Gary, but it's quite a big question, actually. So how does your business model fit with encouraging people to go to renewable energy sources versus retrofitting fossil fuel boilers?
What I'd say is we're not anti-renewable energy. I mean, far from it. If you look at the scale of the problem we're faced with, there's no way we're going to make a quick change to renewables, and the costs and the numbers associated are just too large. I think John mentioned it. There's about 10 to 20 grand is the cost for to retrofit to the green energy, and the majority of people just can't afford that. And if you times that to 29 million, I mean, you've got a very, very, very large number. It'll realistically take decades to achieve that switch. So what we are trying to do is basically offer a bridge in the short to medium term, so that we can remove harmful emissions a lot quicker and for a fraction of the cost, and then provide folks with a bit of breathing space to make a less costly transition to the greener heater sources later on.
Okay, thank you, Gary. So just going to do a quick round the table now for this last question. If we accept that the public sector and the industry has largely accepted some of the quick wins, like low energy light bulbs, insulation, installing loft insulation, what do you think is going to be the next easy quick win for retrofitting? Angel.
Air source heat pumps.
Thank you. Bill?
I agree, air source heat pumps are going to come next, but they come with completely redesigning the central heating system. Yeah, they only operate at 35 degrees C as opposed to 80 degrees C as gas boilers, and that's what the government's not saying. So I'm afraid we have to look at fabric at the same time, else people are going to really complain about their electric fuel bills.
Okay, thank you. Ernie? Next big ticket item in.
Yeah, I think it's electrification. So air source heat pumps are a key part of that. There's a lot of talk about hydrogen and all of the rest, but it involves multiple thermodynamic steps to get to hydrogen, and then back from hydrogen to heat or whatever. So I think electrification and all that goes with that. Air source heat pumps. I've just installed one in a house, and I think it's great.
Thank you. And Gary, just finally you.
Easy question for me. Emissions filter.
Okay. So that brings us to the end of our Q&A session. There was a couple of questions there I didn't get to, but hopefully we can populate them on the website and answer those questions. So just finally from me, thanks for joining today. Thanks for your important questions, and to the panel, Bill, Angel, and our two spotlight sessions, Gary and Ernie. And thanks for sharing your thoughts and a very insightful discussion on Retrofit. We could have had 2 hours, I know that. We have posted a few details for relevant links in the chat, and if you haven't already, please remember to download the handouts before exiting. The next webinar in the series is Building Sustainable Energy Efficient Buildings, date to be confirmed, and all those who have registered today will get an invite for that next webinar as well. The Make It Smart Hub for Construction and Manufacturing SMEs in the Highlands and Islands is part funded by the 2014-2020 European Structural and Investment Fund, and the support from Highlands and Islands Enterprise, Scottish Enterprise and the Scottish Government is also gratefully acknowledged. Thank you for all attending today's webinar, and please complete the feedback form as we do appreciate your views. So let's get connected, get solutions focused, and let's build a bright future for the construction and manufacturing sectors. Thank you all.
Thank you.